I want you to pick up an object, any object, a pen, a phone, a set of keys. Hold it out in front of you. Hold it still. Now let go. What happened? It fell. It hit the floor. If I asked a 5-year-old why it fell, they would say gravity. If I asked Issac Newton why it fell, he would say the earth has a mass. The object has a mass. There is an invisible attractive force between them. F Josena Chak G, hence frac 1 M2, or $2. The earth pulled the object down. This makes perfect sense. It is intuitive. It is what we feel every day. But I am here to tell you that it is wrong. According to Albert Einstein, and explained beautifully by Richard Feynman in his lectures on curved space, there is no such thing as a force of gravity. The earth did not pull the object down. The object did not accelerate downward. The object stayed exactly where it was. It floated in a straight line. What actually happened is that the floor accelerated upward and smashed into the object. And right now, as you sit in your chair, you feel a pressure on your butt. You feel your weight. That is not gravity pulling you down. That is the chair pushing you up. You are accelerating upwards at 9.8 meters per second squared every single second of your life just to stay in the same place. Today we are going to explore the geometry of space-time. We are going to look at Feynman Lectures Volt 2, Chapter 42, and we are going to understand why gravity is not a force, but a shape. We are going to find out why your feet age slower than your head, and why falling is the only time you are truly free. To understand this, we have to break your brain's concept of straight lines. Feynman asks us to imagine a world of 2D creatures. Let's call them ants. Imagine these ants live on the surface of a giant apple, but they are tiny. To them, the apple looks flat. They think they live on a flat plane. They have no concept of up or down. They only know forward, backward, left, right. Now imagine 2 ants start walking. They start at the equator of the apple. They stand 10 centimeters apart, and they both decide to walk perfectly north, parallel to each other, on a flat piece of paper. Parallel lines never meet. They stay 10 centimeters apart forever. But these ants are not on paper. They are on an apple. They walk north. They keep checking their compasses. They are definitely walking in straight lines. They feel no force pushing them sideways, but as they walk, the distance between them shrinks. 8 centimeters, 5 centimeters, 2 centimeters. Eventually, at the North Pole, they crash into each other. Now, the ants are confused. They say, hey, I walked straight, you walked straight, but we crashed. There must be a force. There must be a gravity that pulled us together. They invent a force of attraction. They write equations for it. But we, looking down from the 3D world, know the truth. There was no force. There was no magnet pulling them together. It was just the geometry of the apple. The surface they were walking on was curved. On a curved surface, straight lines, which we call geodesics, converge. Feynman says, gravity is the curvature of the universe. We are the ants. Space is the apple. When you see 2 things falling toward each other, like the earth and the sun, there is no invisible rope pulling them. They are just following straight lines in a curved universe, and those straight lines happen to crash into each other. But wait, this analogy has a problem. The apple is curved in space, but when I drop a ball, it falls fast. If space is curved, it must be curved a lot to make the ball move that quickly, right? But if space is curved that much, why doesn't the room look bent? Why do laser beams go straight? This is where Feynman drops the hammer. He explains that it is not just space that is curved, it is time. In fact, the time curvature is the most important part. To understand gravity, you have to realize something terrifying about your own existence. You are not standing still. You think you are sitting in a chair, not moving, but you are racing. You are moving through time, and you are moving through time at a very specific speed, the speed of light, c-dello. In the 4D universe, space-time, everything moves at the speed of light. If you are sitting still in space, you are moving at max speed through time. If you start moving through space, like in a rocket, you have to slow down your motion through time. This is why astronauts age slower. You're always trading speed in space for speed in time. Now, Einstein says mass bends space-time. The Earth is a heavy ball of mass. It sits in the fabric of the universe, and it bends time. Specifically, mass slows down. Time. Time runs slower closer to the Earth than it does far away. This is a fact. We have measured it with atomic clocks. Your feet closer to Earth are literally aging slower than your head, farther from Earth. The difference is tiny, nanoseconds over a lifetime, but it is real. So picture yourself moving through time. You are a 4D object flowing from the past to the future like a river, but the river of time flows slower near your feet and faster near your head. What happens to a vehicle if the wheels on the left side turn slower than the wheels on the right side? It turns, it curves, because time is moving slower near the ground. Your path through the universe bends toward the ground. You are turning into the Earth. That turn is what we call falling. Gravity is not a force pulling you down. Gravity is your future path, bending into the ground because time flows unevenly. This brings us back to the falling cup. When you hold the cup, you are preventing it from following its natural path. You are applying a force with your muscles to push it away from the Earth. The cup wants to follow the curvature. It wants to follow the straight line that leads to the floor, but you are interfering. You are forcing it to deviate. When you let go, you stop interfering. The cup becomes free. It follows the natural curve of space-time. It doesn't accelerate. It just coasts. If you were the cup, you would feel weightless. This is why astronauts float. They are just falling freely. But the floor is not free. The floor is being held in place by the structure of the building, which is held by the Earth. The floor is stuck. It cannot follow the curvature. So, relative to the natural geometry of the universe, the floor is accelerating upward, and bang, the floor hits the cup. Feynman explains this using the bug on a hot plate analogy to help us visualize curved geometry. Imagine a metal plate. We have a rule. Metal expands when it gets hot. Now imagine we put a heat source in the middle of the plate. The middle is hot. The edges are cool. We put a bug on the plate. The bug has a little ruler. He wants to measure distances. When the bug is in the center, hot, the ruler expands. It gets bigger. When the bug is at the edge, cold, the ruler shrinks. But the bug doesn't know this. He thinks his ruler is constant. If the bug tries to measure the radius of the plate and then the circumference, the math won't work. C dollars will not equal 2 pi, because his ruler keeps changing size. The bug will say, my geometry is broken, space is curved, or the bug might say, there is a mysterious force distorting my measurements. We are the bug. Gravity is the heat. Mass heats up the plate of space-time, changing the scale of length and time, and we perceive that distortion as a force pulling us down. So why does this matter? Why is this more than just a word game? Because it means that inertia and gravity are the same thing. Think about being in a car. The driver slams on the brakes. You fly forward. Did a force push you forward? No. You were just continuing your natural motion. The car stopped, and you kept going. That feeling of being thrown forward is pseudo-force. It feels real, but it's just inertia. General relativity says gravity is a pseudo-force. The feeling of weight you have right now is exactly the same as the feeling of being in a car that is speeding up. You are in a spaceship called Earth. The geometry of the universe is accelerating the surface of the Earth into your feet. This is the equivalence principle. If you were in a rocket in deep space, accelerating at 9.8 ms2, you would feel exactly like you do now. You could drop a cup, and the floor of the rocket would rush up and hit it. It would look exactly like gravity. Einstein realized if you can't tell the difference, there is no difference. So the next time you drop something, don't look at it as a failure. Don't think it fell down. Think it became free. For a brief moment, that cup was doing exactly what the universe wanted it to do. It was following the path of least resistance. It was surfing the ripples of space-time. And you are the one fighting the universe. Every moment you stand up, you are fighting the geometry of the cosmos. You are a biological machine using chemical energy to push yourself away from your natural path. Gravity isn't a master that enslaves you. Gravity is the shape of the home you live in and the struggle to stand up. That is the struggle of life against the curvature of time itself.